This is assuming that if, let's say, a coupon is expected to be paid on the 15th of March 2024, right? So even if that is a Sunday, it will still assume that it will be paid, which is of course not true because it's not going to be paid on a Sunday. It will be paid the next working day. If the next Monday is a working day, then it will be paid on Monday. So it ignores the street convention, ignores weekends and holidays, whereas your true yield adjusts for weekends and holidays. So this is based on the actual number of days. This is based on the 3360, that there are 30 days in a month and there's 360 days in a year. That's the street convention, right? The true yield takes into account the actual date on which the coupon is going to be paid, and it does the whole calculation based on the actual date to the extent that it will be 365 days, right? And if it's a leap year, then even that is going to be adjusted. So that is your true yield. Of course, it's more accurate. Now, the government equivalent yield is also based on the actual, and it's a semi-annual yield, right? Why it's a semi-annual yield? Because government bonds are semi-annual. Therefore, the government equivalent yield is to compare it to the government bonds, and the government bonds are semi-annual. And the current or simple yield is very simple. You take the coupon amount and you divide it by the current price. So what that means is, let's say there's a bond trading for 99 and it's going to pay you a $5 coupon every year, right? So the current yield will be 5/99. That's it. What this ignores is that this bond is going to, let's say, pay you 100 at maturity. So it ignores that $1 that you also will earn because you paid 99 for it, but the face value is 100, right? So it ignores that. That's why it's called simple yield, because it is ignoring that price component. So as discussed, street convention is 3360 and doesn't adjust for your weekend or holiday, whereas your true yield, it's based on the actual calendar, makes an adjustment for the weekends and holidays, right? And let's compare your street convention to the true yield. So if it's written as per the bond indenture, which is the contract, that the coupon date, let's say, falls on the 15th of March, and that happens to be a Sunday. So in the street convention, we'll just assume that that payment will be made on that day, which is obviously not true because it will not be made on the Sunday. It will be made the next day, which is going to be a Monday, and that also assuming if it is going to be a business day. There could be a holiday on Monday as well, right? So assuming there's no holiday on Monday and it's a business day, so the true yield will then assume that the payment will be made on Monday and not Sunday, and then it will take that date, specifically that date, into account. Government equivalent yield is used for US Treasuries, which are semi-annual. And another important thing I want to tell you is that, when we make the yield curve, and yield curve is very important because it helps us figure out that for varying maturities, right, what is the yield on government bonds. So it tells us, okay, what is the risk-free rate for different maturities, and we use it in various ways. Let's say I want to come up with a corporate bond and I want to have a spread over the government securities. So unless I don't know what the government securities is, then how am I going to use that as a benchmark? Now the problem is government bonds, and so there is US Treasuries issues three types of securities. One is called a treasury bond, one is called a treasury note, and one is called a treasury bill. Now, these two are greater than 1 year, right? And treasury bills are less than 1 year. So, treasury notes and treasury bonds are what are the government equivalent yield, that they are quoted in that government equivalent yield. But this part, which is your T bills, comes under money market, right? And that is quoted in a different way. So to be able to put this yield curve together, we need to take those T-bills and take their yield and convert them into the government equivalent yield so that we can put this yield curve together. So that is how this is used, right? Okay. Now the simple yield or the current yield is very simple. You just take the coupon amount and divide it by the price. So let's say 8% semi-annual. So what you could do is 8 divided by 2, 8% divided by 2 multiplied by 100 gives you 4. But then you have to look at the annual basis. So you'll multiply it by 2 again and you will get $8, right? And you'll say, okay, $8 divided by the current price. Oh, sorry, it's not $8. It's $1,000 bond because it's priced at 960. So then you have to assume that it's going to be round value of 1,000, which means this is going to become 40 into 2, which is 80, right? Or you could just directly say 8% of 1,000 instead of dividing it by 2 and then later multiplying it by 2, because you have to calculate the annual amount anyways, and it comes to 80, which is the coupon. Current price is 960 and you get your simple yield or current yield. Very, very straightforward. Right. Now entering into the world of callable bonds. Let's take an example. Let's say Amazon obviously has their equity capital from their shareholders, right? And let's say they want some debt from you. So they're willing to give you callable bonds and they want you to pay for $100 each. They're saying we're going to pay you 5% coupon on this. And let's say the current interest rate is also 5%. So, or let's say it's a little bit less than what Amazon is paying you. Let's say it's 4.9%, right? Because obviously Amazon has to pay you more than the government. Otherwise, you could just give your money to the government. Now, let's say the interest rate goes down to 4%. Amazon will be thinking, hey, why am I paying 5% on these bonds? Let me call them back. So only if they are callable, that is, there is an option embedded in that bond that it is a callable bond, then what will happen is that they will call these bonds back and you will be very upset. Why? Because you were hoping to make 5%. Now they will call the bonds back, give you your money back, right? And you will have to go and invest it at 4% in the market. And they will probably issue new bonds at 4.1% or something. But the point is that a callable bond is something which can be called back by the issuer, the company. Now, obviously, you're not going to be very happy because you were hoping to make 5%. And now these guys, before the maturity date, are telling you, hey, here's your money back, right? And we are not going to pay you 5% anymore. So at the time of selling this bond to you, they tell you upfront that, hey, this is a callable bond and we can, before maturity. So let's say the maturity is 2026 and they tell you that even 2025 we can call it back, even 2024 we can call it back, and you're buying it in 2023. If they don't call it back, they will pay you that $100 face value eventually. They'll pay you that 5% for 2025. They'll pay you that 5% for 2024. However, if they call it back for 2025, they will pay you a little bit extra, let's say 100.5, just to compensate you because they're calling it back a year early. Now you might be thinking, why are they compensating me? They're giving me my money back early. Well, they're compensating you because the only reason they will want to give your money back early is if the interest rate drops in the market, right? Or their credit rating improves further, which means they don't have to pay 5%. Maybe they can get it at a lower rate. But either way, they don't want to pay you this high rate anymore. And that's why they want to give you your money back early. And maybe you're a pension fund and you had already planned to receive this 5% for the next 3 years. And they're paying you early. So that's why they compensate you a little bit. If they pay you back within 1 year, maybe they'll pay you $1 extra, right? 101. So these amounts, these call prices, they will be mentioned from before. And the call dates will also be mentioned from before, that on what dates can it potentially be called, and if it is called on those dates, what the call price is going to be. And let me just move to the next screen. So, and for each of those dates, what will happen is that you have 3 types of callable bonds. One is an American call option, a European call option, and a Bermudan. Now, there will be a certain call date. So coming back to that discussion about 2024, 2025, and 2026. Let's say they have a certain call date, right? And the first one is 2024, which means for the first year, you're going to get your 5% for sure. At the earliest it will be called back is 1 year from the date of purchase. So that's a call date, right? Now, in the case of an American, any time after the call date, right? So any time after the call date, it can be called back. There's no need for a call schedule. European, only once after the call date. Bermudan, on the other hand, has a call schedule. Now, what does that mean? That means that they will give you a schedule of call dates and call prices, where they will say, okay, if we call it back in 2024, we'll pay you 101. Instead of that $100 face value, we'll pay you $1 extra. If we call it back in 2025, we'll pay you 100.5, right? And of course, if it matures at its normal maturity, 2026, we'll just pay you that 100. Now, what does yield to call mean? That you can calculate the yield to each of these different calls. Let's say, for example, it doesn't get called in 2024. It doesn't get called in 2025, right? It stays alive till maturity. So you get 5% here, you get 5% here, you get 5% here, and then you get the face value. In that case, when you will calculate the yield, it will be N is equal to 1, 2, 3, right? Payment, let's say if it's an annual, so it'll just be $5, 5% of 100. Present value, let's say you're buying it for 100. So present value will be minus 100. Future value will be plus 100 because that's what you're going to get at maturity. And then you can just calculate your I by Y, and that is your yield to call, because it's basically not getting called till the maturity. So I by Y will be your YTM, yield to maturity. Now let's say it's not going to stay alive till maturity and it gets called over here at a price of 100.5. So the first thing you're going to do is the I by Y is not going to be yield to maturity anymore, because it's not going till maturity. It's going to be a yield to call. And which call? The second call, right? This is the second call, this one. Let's say this is the first call, 2024, and 2025 is the second call. We're saying it made it past the first call. It wasn't called back. Second call, so yield to second call is we're calculating. What we're calculating, the face value changes to 100.5 because you will get extra and n goes down to 2, right? And then let's say you want to do yield to first call. So yield to first call will be, instead of that 100.5, right, you're going to get 101, and it doesn't make it beyond that. So your n goes down to 1, your face value goes down up to 101, and then you get your yield to first call. So this is basically your yield to first call and your yield to second call. And the worst of those, whichever is the lowest of, and there could be a yield to third, yield to fourth, depending on the call schedule. Whichever is the lowest will be the yield to worst. Now, you might be feeling a little bit confused, so we're going to do a few questions and it will make sense to you. But before I jump into those questions, I just want to explain option adjusted yield. So again, with the Amazon example, and you buying this callable bond, and Amazon is saying, hey, it's for $100. And you're like, no, I'm not paying you 100 for this. I'm going to pay you 99.5 because this is a callable bond. Anytime you can call it back. So I want a discount on this because you, as the issuer, as the company, Amazon, are having this added advantage that anytime you want, you can call it back, or based on a certain call schedule, you can call it back. So I will be paying a lower price for this. Right? So whatever the N is and whatever the PMT is, whatever the FV is, whatever the PV is, determines the I by Y, right? So if the PV is lower, if you're paying a lower rate, naturally the return you will earn on that will be higher. But if we want to know what would be the I by Y if the PV was the full 100, so all we have to do is, instead of taking the actual price, we just have to take the price. If it were non-callable, then obviously the price would be higher. Maybe it would be 100, maybe it would be something else, but it would definitely be higher than what you're paying, because you're paying a low price right now because it's a callable bond, which is something that the issuer has an advantage in issuing. So all you have to do is take the price if it were not a callable bond, and that will help you calculate the yield, which is called the option adjusted yield. By the way, bonds can also be puttable, which means that the investor can put it back to the company and take their money back before maturity. And in that case, the investor wouldn't pay a lower price, the investor would pay a higher price for it. And if you would want to calculate the option adjusted yield for a puttable bond, then you would take as if the bond were non-puttable, right? As if the bond were non-puttable, in which case the price would be lower, because if you're going to buy a puttable bond, you're probably going to have to pay a premium for buying it, because you can give it back to the company anytime and take your money back. Okay, so as promised, let's get our hands dirty a little bit and do some calculations. So before you pause the video, let me just help you wrap your mind around this question, and then I can request you to pause the video and try to solve it. First of all, calculate both the yield measures. So what are those both yield measures? Current yield and yield to maturity. Current yield, obviously you have to take the coupon amount, annual coupon amount divided by the current price. And yield to maturity, you have to use your time value of money functions. Just be careful that what you're going to set your N as, right? And let me just help you out a little bit. N here will be 4 into 4, which is 16. And N here is going to be 4 into 2, which is 8. So that's all I'm going to tell you, just to get you started. And please calculate yield to maturity and current yield for these two. Okay, so hopefully you were able to calculate the current yield for bond A, which is 6% into 100, which is $6, divided by the price of 95. And the current yield for bond B, 10%, gives you a $10 coupon divided by 110. So that was fairly straightforward. Now, The yield to maturity is also simple for you if you used your time value of money correctly. So N for bond B would be 4 years into quarters, 4 quarters, so that would be 16. Your PMT would be $10 divided by 4. So 10 divided by 4, that is 2.5. Or if you want me to write the full, basically it's 10% divided by 4 into $100, which is $2.5. So N is done, PMT is done, FV is 100, PV will be negative 110, and you can just calculate your I by Y, which is obviously going to be for the quarter, and you multiply it by 4 to get the annual, which should be equal to, for bond B, 7.106. And for bond A, your N will be 4 into 2, which is 8. PMT will be 6% divided by 2, which is $3. And your PV will be negative 95, FV positive 100, and then you can just calculate your I by Y. Don't forget to multiply it by 2, which will give you 7.469. So coming back to the previous slide where the second question is mentioned, that this is 7. Actually, let me go to the next slide and explain to you how to solve this one, because I need to remind you of the formula for converting one stated rate to another. Now this is stated rate, and also, by the way, I need to remind you for one more thing, which was written in the slide when we talked about it, but I just want to speak about it as well. That stated rate can also be written as APR, right? So this APR, this bond B APR, this is a quarterly stated rate, right? And this bond A APR is actually a semi-annual. Now they want us to compare A and B, but you cannot compare apples and oranges. So if you want to compare B to A, you need to first take B and bring it to a semi-annual basis, right? It's a quarterly basis right now. And if you remember this formula, 1 plus APR 4 divided by 4 to the power of 4 is equal to 1 plus APR 2 divided by 2 to the power of 2. And this is, since it's a quarterly one, so you can just replace that 0.07106 over here. And you can solve for the APR2, which will give you the stated rate for bond B if it were stated in a semi-annual basis. And then you can compare those two. So let me just solve this for you. 0.07106 divided by 4 plus 1 to the power of 4. So this side becomes 1073 and is equal to 1 plus APR 2 divided by 2 whole square. Let me take under root on both sides to get rid of that square. So now I get 1.0358 is equal to 1 plus APR 2 divided by 2. Then I'll just take the 1 on the other side, so minus 1, and then multiply it by 2. And what I get is APR2 is equal to 0.07169. So when I convert this stated rate into a semi-annual stated rate for bond B, it comes to 7.169%. Right? And that's what's stated over here. The 7.106 becomes 7.169 if it was a semi-annual. Now I can compare these two, 7.169 and 7.469, and the difference of 30 basis points, so 0.3%, is the additional compensation for bond A. Right. Another question yield to first call and yield to second call. So this is your first call, 102 is the call price, and this is your second call, 101 is the call price. Now please pause the video and solve it yourself. Okay, so hopefully you were able to do it. Obviously n is going to be different for both. So here we've got 1, 2, 3, 4, 5. So n is going to be 5 for the first call, right? And then 6, 7, 8. So n is going to be 8 for the second call. The FV will be 102 in the case of the first call and 101 in the case of the second call. Everything else should be the same. Present value, payment, yeah. I by Y, of course, you have to calculate, and that comes to 10.32 and 10.09. By the way, which is going to be the yield to worst? You should calculate the yield to maturity as well and then see which one is the worst. So that is something for you to do on your own. For me, I'm going to give you another question where you actually have to calculate the yield to worst. But before you can calculate the yield to worst, first yield to first call, then obviously to be able to calculate the yield to worst, you have to calculate the yield to second call and yield to maturity, and then tell me which one is the worst. So what did you guys get for the yield to first call? Hopefully you got that 5.2684, right? And if you're doing it because it's a semi-annual basis, right? So you have to obviously do it in for like 1 year. It's going to be actually n is equal to 4. And then once you calculate that I by Y, you have to multiply it by 2. So that was one additional step over here. And which one is the yield to worst? So your yield to first call is 5.27, yield to second call is 4.84, and yield to maturity is the lowest, 4.52. So that will be your yield to worst. Right. So let's take a break here, guys. Get fresh, and then we'll come back and talk about yield spread measures for fixed rate bonds and have another discussion related to matrix pricing.